Okay, subtracting polynomials, lesson 4. So to symbolically subtract two or more polynomials together, follow the steps. Step 1, change the sign of the terms being subtracted. This is known as distributing the negative. So yesterday, in our examples, we would find a good one here. For example, here, you had to distribute the negative 3. And I kept saying you need to include the negative, include the negative, include the negative in your distribution. So today we are distributing, but you kind of have to picture it as there's a negative 1 there. So when you're distributing this, include the negative. The first part is kind of like just a positive 1. So if you distribute a positive 1, all you end up with is exactly the same thing. So we can remove the brackets of the first binomial there. Now in this case, when we're distributing this negative 1 multiplied by 2x gives me negative 2x, and negative 1, make sure I'm using the same color, negative 2x, and then negative 1 multiplied by positive 4x actually gives me negative 4x. So if you notice, the signs of the second binomial here, this was positive, and this was positive. They've both become negative. And then we can collect our like terms. So if we rewrite this, it's going to be negative 3x squared minus 4x squared plus 4x minus 2x. And this will simplify to negative 7x squared and positive 2x. And that would be our solution. Let's do another example here. So the first term, there's no sets of brackets, so we're just going to rewrite the first 3 things there. But then we're going to distribute this negative. So this x squared is going to become negative x squared. The positive 5x becomes negative 5x. And the negative 6 becomes positive 6. If we rewrite it, and then combine, we've got x squared, and those two will make negative 8x, and finally positive 10. Okay, the last one again, there's nothing to distribute here, a 1, but the first term is just going to remain exactly like it is. So you've got 3x squared plus 5x minus 4. Now let's distribute this negative. So the positive 7 becomes negative 7. The negative 4x becomes positive 4x. And the positive 4x squared becomes negative 4x squared. So then if we rewrite and collect all our like terms, 3x squared minus 4x squared, and we're sure to keep the same signs that are with the values, negative 4 and negative 7, and 3x squared and negative 4x squared simplify to negative x squared, and then 5x and 4x will simplify to 9x, and then negative 4 and negative 7 will simplify to negative 11. Algebra tiles can also help you understand the subtraction of polynomials. When subtracting polynomials, change the signs of the tiles being subtracted and change the subtraction sign to an addition. All right, so what does this mean? Well, the first set of algebra tiles is going to remain exactly the same. So we've got negative 1, negative 2x squared, negative 3x squared, and then we've got positive 4x. Now the second part here, we're going to change to addition. So this becomes an addition sign. And the stuff on the right, we're going to change the sign. In this case, the color. So the two x's become negative x. The two x squareds become negative x squared. And the 3 1s become positive 1. And then we can collect like terms and see what we got. So the original ones, we've got -1, -2, and -3x squared. Then we're going to collect the other -2x squared. And then we've got the, we can create a zero pair here. So 2 of these and 2 of those make a zero pair. So what are we left with? Just positive 2x. And then there's no zero pairs to be made with the ones, so we are left with the 3 ones. And this is -5x squared plus 2x plus 3. So let's try another one here. Keep the first set of algebra tiles exactly the same. So x squared, negative x, negative x, negative x, and +1, +1, +1, and +1. Change to addition, and then change the sign. So that becomes -x squared. These ones become -x. Sure got the right amount. And these ones become +1. All right. See if we have any zero pairs. And in fact, we do. This one and that one make a zero pair. And it appears that that's it. So let's rewrite what we have down below. Let's use the right color. So we've got an x squared. We've got 1, 2, 3, and then 5 more. And then we've got 10 of those, and they're all shaded in. And so then we can write the algebraic expression for this. We've got x squared minus 8x plus 10. Well, we can use this concept in other areas. So a perimeter question. Now remember, the perimeter is the sum of all sides. And in this case, we're given the perimeter. We know what it is, but we're missing one of the sides. So what we can actually do is take the perimeter and subtract the unknown side. So we're going to start with the perimeter, 5x squared plus 7x plus 12. And we're actually going to subtract the other two sides. So subtract 2x squared plus 5 plus 3x squared plus 9x. All right. The 2x plus 5 shows up there, and the 3x squared plus 9x shows up there. Okay. So let's, first of all, we could collect a few like terms on this side, the 2x squared and the 3x squared. So let's just simplify things a little bit. 5x squared plus 7x plus 12. And then the 2x squared and the 3x squared make 5x squared. And that's it. So 9x plus 5. Okay, so here's the part where we distribute the negative. So 5x squared plus 7x plus 12. The 5x squared becomes negative 5x squared. The positive 9x becomes negative 9x. And the positive 5 becomes negative 5. So let's rewrite 5x squared minus 5x squared plus 7x minus 9x plus 12 minus 5. All right. 5x squared minus 5x squared, well, that's a zero pair. The 7x and the negative 9x will simplify to negative 2x. That's that part. And then the positive 12 and negative 5 will simplify to positive 7. So the missing side is negative 2x plus 7. And there we go. Given the figure below, write a polynomial expression to represent the area of the shaded region. Okay, well, if you think about the problem, what we want to do is take the big area and subtract the small area. So first off, the area of the shaded rectangle is going to be 4m, is going to be 7m multiplied by 4m plus 3. So if you distribute here, we're going to get 28m squared and positive 21m. And then the area of the unshaded square, the smaller one, is going to be 4m multiplied by 2m minus 1. So we get 8m squared and negative 4m. So let's figure out the area of the shaded part. Okay, so we're doing the big area minus the small area. So we've got 28m squared plus 21m, and we're subtracting 8m squared and negative 4m. So distribute this negative to both terms. So 28m squared plus 21m minus 8m squared, and this becomes positive 4m. Rewrite it. And then simplify. 28m squared, subtracting 8m, gives me 20m squared. And then the 21m and the 4m will become 25m. So the area, I should have done the area of the shaded part. So the area of the shaded is 20m squared added with 25m.